Hello.
Good morning.
Welcome,
Hello.
gentlemen. Hello. Hello. Just wait a couple minutes for people to trickle in. I'm gonna paste in and just put together a quick and dirty HackMD. I'll share my screen in a moment. Can everybody see my screen?
Yep.
Cool. Let's see, what time is it? Maybe give it one more minute in case anyone else arrives, and then we'll get started. Okay, let's dive in. Um, okay, thank you everybody for coming. Just wanted to kind of kick off, hopefully, some or maybe broaden the scope of knowledge of what's going on with async. As you may know, I've been working with Luke and others on kind of fleshing out the async specification along with an implementation. And this started actually over a year ago with some experiments. I've always been interested in kind of cooperative concurrency models and so on, and was really interested in cracking the problem of composable concurrency in WASI and the component model and had even before I started at Fermyon, actually, I had been watching some of the videos that Luke had produced with his early visions of async, and so have been lucky enough to been allowed the time from Till and others at Fermyon to actually work on this. And I put up an RFC a couple months ago on the Bytecode Alliance RFCs repo. If you haven't had a chance to look at that and you're interested in the topic, please do take a look. That has kind of a more fleshed out version of what we'll talk about today. And not only is the RFC up there, but I've implemented pretty much everything I said I was going to in the RFC, modulo some corner cases and bug fixes and so on. Uh, with that said, the current status is we're pretty much feature complete. There's a couple details that need to be taken care of. Victor has volunteered to work on implementing debug context new and debug string. We're already plumbing it through wasm-tools and wit-bindgen and whatnot. So there's not a lot left to do there, but I wanted to leave that in place, and we've already kind of synced one-on-one about what that looks like. Shouldn't take too long to do that. And then Luke has already, based on conversations we've had recently, put up a PR to simplify an aspect of the specification that'll also simplify the implementation. I haven't actually reviewed that PR, nor have I implemented the change yet, but that's on the radar. And then waitable sets. Won't go into detail about what that is, except to say that we believe we'll need that for applications for WASI-libc in particular, being able to implement POSIX, pull, and select efficiently and sanely, being able to kind of group subtasks and streams and futures into sets and be able to essentially wait on those, elements of those sets without waiting on everything, which is the current way test.wait works. So that's our status. Got some PRs up for wasm-tools, wit-bindgen, and wasmtime. The wasm-tools and wit-bindgen ones are ready to go. The wit-bindgen one's still in draft, but that's only because it points to the fork of wasm-tools temporarily, and we'll obviously address that before we merge. Wasmtime is not in as great state. It's rapidly improving. The code is pretty awful. I apologize in advance if you've actually taken a look at it. But it's getting better, and I'm trying to the remaining items on my to-do list. I'm taking a test-driven development approach to it. So I'm going to get some tests in there, get some failing tests going, make those tests pass, and hoping by the end of the year it will actually be ready for review. Any questions before we dive into the details? Okay. And obviously well, maybe not so obviously, I should mention that Luke has merged, other than the to-do items I mentioned earlier, has merged async specification kind of details into the explainer.md and so on in the component model repo. So if you have any questions about, at a high level, how the specification works, please take a look at that, and I'm happy to answer them here as well. And so I'll probably go through wasm-tools and wit-bindgen pretty quickly, because I think we've mainly got a wasm-time heavy audience here, and that's where the interesting bits are. Wasm-tools, there's not actually a lot to be said. There's not a lot of room for novelty, just following the current architecture of how wasm parser works and wit component and whatnot. The couple things I'll note is just that, it's feature gated, so WASM parser by default will not will complain if you try to use some of this new stuff. And then wit component, there was a little bit of room for creativity there because I had to come up with some sort of naming scheme, name mangling scheme, so that, say, for example, wit-bindgen generated code could specify which lifting or lowering ABI that it wanted to use, sync versus async versus stackful versus stackless, etc. So I just made stuff up that seemed sane to me. We also have this build targets.md proposal to standardize the tooling interfaces for name mangling. And I haven't even tried to guess at what those standard name manglings will be. So if you tell wit component to use the standard name mangling and then try to use any sort of async thing, it won't know what you're talking about. It won't recognize async or anything like that. So that's a to-do item. Otherwise, not much to say about wasm-tools. Wit-bindgen, so far just Rust language support. Of course, wit-bindgen, the repo, has support for C#, C, Go, etc. Only tried to tackle Rust so far. Am planning to implement it for other languages once we kind of get all the foundation stuff in place. You can now optionally generate bindings for async imports and stackless async exports. And by stackless, I mean there's two ways the async ABI works for exports. One is where you specify callback, which basically means stackless, which means you are telling the host that you are going to return control to the host by actually unwinding the stack back up to the top level export and returning control to the host, saying I'm not done yet because I'm waiting on these various async imports that I called, but please call this callback function when progress is made on any of those async import calls. That's in contrast to the stackful mode, which is you don't specify a callback and you use a slightly different API as a result. And that basically means, no, I'm not, actually not going to unwind the stack. I'm going to call task.wait. And by calling task.wait, I'm inviting you to return that from that task wait call whenever progress is made on any of the outstanding calls I've made. And also, if you want to, create another stack and call into this same instance. So re-enter on another stack. And this doesn't actually rely on core stack switching, but it anticipates core stack switching. And it basically requires that the guest be prepared for multiple concurrent WASM stacks, not multiple parallel stacks, that would be threading, but multiple concurrent stacks. Okay, so there's all that support. There's this new module added to the wit-bindgen RT crate, which has async support, which has some helper modules, or helper functions, which the generated code will use when you actually opt into this async paradigm, as well as some functions that you can call directly from your application code, including this spawn function, kind of modeled off of, if you're familiar with Tokyo, Tokyo has a spawn function. Here, we're not really spawning like a whole new another thread, but rather we're just saying, I've got a future that I want to defer to actually run after I return a value, because one of the innovations with this new async API is an async export is allowed to continue executing after it's called this task return built in to return a value to the caller and actually run additional code. And this has two implications. One is this, if you're familiar with the post return paradigm that we've used up to this point for actually like it's in the name, post return execution, it kind of flips that around. So instead, now we call task.return, and then you can keep running rather than have the host call the export and then call the post return. So that's described in detail in the specification, but this is how we sort of expose that in Rust. I'm open if we feel like that's not the most idiomatic way to do that, we can talk about that. But for now, that's how I've done it. And then also you could call async imports from a synchronously lifted export. And that's where block on would be useful because you're not actually in an async context, but you can, using this task.wait intrinsic, call async lowered imports and then kind of do a Tokyo style block on. So there's that. Then for streams and futures, we basically translate, just as a reminder, streams and futures, the way they work is when you create a new stream or a future, you get a single handle, but you can, how do I describe this? But you can read from or write to that handle, and then you can share the read end with another component or with the host by either returning it from the current function that you're exporting, or by passing it as a parameter to an import. And then that sort of splits the stream up, and then you can, at that point, you only have the write end, and you've given away the read end, and you can write as much as you want. And then you can create what arbitrary topologies by, again, either returning a writer to a caller or passing a writer to a callee, and kind of create whatever networks, and then they can pass that on to other components if they want to, etc. And then as sort of a default implementation, I kind of used the futures crate, which is somewhat popular in the Rust ecosystem. So stream reader implements stream, and sync implements, or stream writer implements, I'm sorry. Yeah, stream writer implements sync. And then we generate these, we've got these two new traits called stream payload and future payload, which we automatically generate implementations for based on the world that you're targeting. And that takes care of the lifting and the lowering and the canceling and the dropping and deferring to the low-level intrinsics that handle that sort of thing. So there's that. And then finally, in wit-bindgen core, I've added support. If you're familiar with wit-bindgen, there's this abstraction, there's this core crate that is shared by all the language implementations that for code generation. It's kind of like this little abstract sort of virtual machine that gets implemented by each language that produces stuff, produces code for these sort of like high-level instructions that are defined in wit-bindgen core. So I had to define some new instructions for handling async lifts and lowers. And just an FYI, those will probably evolve and change as, they might be accidentally Rust specific. And so we'll have to, modify them as we add C support and C# support, et cetera. Any questions about wit-bindgen? Yes, Nick, please.
Um, so am I understanding correctly that the Rust toolchain support only uses the non-callback version of the ABI?
It only uses the callback version, the stack list, the callback version. Yeah.
Uses the
Uh,
callbacks.
yeah.
Okay.
And part of the reason for that is a prerequisite for I do actually have some tests in Rust for the stackful ABI, but I have to be really careful there because I can't use the LLVM shadow stack
Mm.
during a call because otherwise, I won't be reentrant. It's specially written without using wit-bindgen at all. I kind of use the raw calls and have to write, and there's lots of comments in there about how I did that. But otherwise, the callback full, in other words, the stack list one is very easy to implement because we don't have to worry about, that kind of reentrance.
And so is there any implementation at all that uses the stackful version at this
Not
point?
yet. I'm anticipating that Go definitely will,
Mhm.
for Go routines, basically. Um, and possibly Java if we ever move the Java, folks
Mhm.
forward. Um, those are
Have
the ones
you
that I expect. Yeah.
have you talked at all with Damien by chance?
I haven't talked with Damien. I talked with Randy Reddig
Mm.
at WasmCon a little bit, very briefly, but yeah, I'd be interested in engaging with the Go folks.
Cool. Thanks.
This is also the question I was going to ask about the stackful stuff in the sense that do you feel like all of the bits necessary to implement a stackful implementation are there in terms of like the component model ABI style aspects, or is this stuff where like we're sort of basically assuming everyone's using callbacks and we'll add stuff for stackful things eventually?
Well, like I said, I do have tests, and I've tested end to end the stackful thing using my carefully written. And of course, you can do it if you want to write. Originally, I was planning to write raw WAT just to avoid any chance of like shadow stack being messing me up here. Um, it didn't come to that, although I probably will end up doing that for as I continue adding tests to Wasmtime. Um, I I mean, so far so good. It certainly it worked. I was able to do. I actually verified that it was actually re-entering on another stack. By adding strategic print statements and whatnot. So it's working in the simple cases that I've used, and they're not trivial cases either. I mean, it was passing values in and out, and actually composition. I composed I have all these every combination you can think of, stackful, stackless, using WASM compose and calling each other. So the fused adapting works as well. So it's as signs are good so far. I guess I'll summarize it now.
Because the main thing that I'm curious about is sort of uh, like what you have is great, and that all makes sense. But I also mean in terms of like feasibly getting towards something that actually manages the shadow stack in the sense that
Mhm.
without management of the shadow stack, it's a complete non-starter for like Rust and Go and LLVM and everything like that. So I'm
Right.
curious, do you feel like there's a good trajectory towards eventually managing that, or is it still kind of like that sort of we'll just deal with that when we get there?
Yeah, good question. I mean, there's two questions there. One is, do we ever want to steer folks who are doing Rust to a stackful mode? Like maybe we do. I mean, I know there are libraries out there for, that actually, have want stackful coroutines in Rust, and they provide that. And maybe people, I just don't know if that's popular enough that we actually want to concern ourselves with it, or if the folks who actually care about it should maybe, step up and help with it. I'm not sure. I think where it really matters is Go in my mind, most urgently. And there, I'm actually a little not. I'm not sure exactly how that works. I don't even remember whether Tiny Go uses LLVM or Big Go uses Yeah, I don't know how that all
Uh,
works.
TinyGo uses LLVM
Okay.
and Asyncify
Yeah.
um, to CPS essentially,
Hmm.
and then do the switching that way.
Yeah.
Uh, I know less about Big Go. The hope is for TinyGo to switch over to stack switching,
Right.
um, but I don't know if just this would be enough to let them stop using Asyncify. I think probably not, because there would still be, you know, Go routines that would need to switch even when there's not like IO or whatever.
Yeah, so on the toolchain side, definitely, if the TinyGo folks, if they're using LLVM and they don't want to use Asyncify anymore, which is what I would expect, then yeah, that is going to put pressure on, and just stack switching in general, kind of orthogonally to the component model async, is going to need some solution to the shadow stack issue, it seems like. So whether this is the forcing function or stack switching is the forcing function, it seems like it's going to need to be addressed.
Do you feel like so all the work you've done right here, you've kind of all gated it behind like component model async as a feature.
Mhm.
Do you feel like we want to ship that in its entirety eventually, like as sort of the initial MVP, or do you feel like we're going to want to slice and dice it even further? So like one example is that to me, I've never understood the Stackful API. I don't think it's ever going to work personally. I think we're always going to want to get it via stack switching. As in, once we have stack switching, there is no need for the Stackful API whatsoever because you can rebuild all your language stuff on top of stack switching. It's like,
Wait, sorry. I think just terminology clarification. By stackful, I think you're referring to what I'm calling stackless, which is
oh,
with the callback. The thing that involves the callback, you're saying we don't need long term.
no, the other way around. I'm actually
Okay.
saying, wait,
Because stackful
uh,
means stack with switching in my mind, or at least a primitive version of stack switching.
and like Rust async stuff is using the callback right
Is
now.
the using the callback. Yeah.
Right. So in my mind, that's the only one we want. And if we can do everything with that, if we have native stack switching in WASM. So if we have native stack switching, you can build everything for Go, for C, for Python, for Java, or whatever. Like they do native stack switching to create the callback API around the edges, and then Rust would
I
not
see what
actually
you're
do that. Rust
saying.
would do the
Okay.
like so. That's
Yeah.
just sort of. I'm not saying we should go one way or another. I'm just saying
I
that's an
see.
example of
I
like
hear
maybe
you.
slicing and dicing things.
I hear
So
you.
have you been thinking that, or have you mostly been thinking of like component model async as this one atomic thing that's going to ship all the time?
I have been thinking of it more of as an atomic thing, but I mean, yeah, you raise an interesting point that, yeah, if we do have stack switching, yeah, I honestly had not thought of it the way you're describing it until now, but it does make sense, which is, yeah, you have explicit guest-driven stack switching that uses the callback API to kind of, to return as necessary. Uh, yeah, I was actually wondering if it was the opposite, if to the extent that I was thinking about this at all, which was like, would we eventually get rid of the callback version and just assume stack switching was safe and correct, and that you always use task.wait. But yeah, I could see both ways.
I don't think we would want to always use the stack full
Hmm.
version
Hmm.
because that forces allocations of WASM stacks at the
Correct.
runtime level, which
Yeah.
is going to be a lot more expensive than what Rust is doing inside the one WASM stack, right?
Yeah. Yeah. Good point.
That's always what I've thought as well, which is the callback stuff is the actually performance side,
Hmm.
and we'll be able to get stack fullness a little bit performant. Like if you,
Right.
as
Yeah.
in
Yeah.
the steady state of having a set of stacks going
Mhm.
between them is like nice and fast,
Mhm.
but the rapid creation of stacks is unlikely to ever be really that fast.
Yeah. I don't want to get too much into the weeds with this, but I will mention one other thing that came up when I was discussing something similar with Luke, which was that we may need to conservatively allocate a fiber even for when calling stackless, i.e., callback based async exports, because we have not disallowed the ability to call a synchronous import from an async lifted export. And part of the reason we haven't disallowed that is because a lot of times you just want to do like a print line or something like that. And technically that's blocking, but you want kind of just you're just debugging or something like that. And uh, uh, so the feeling was that we might, unless we do like some ahead of time static analysis, see and just prove that, oh, this is actually well behaved. You never will call a synchronous call anywhere. I'm going to conservatively assume that you might, and then I'm going to give you your own fiber so that I don't block any other subcomponents you were in that same instance that you were composed with. Um, so it's food for thought. I don't want to get too bogged down in this discussion, but there's and I was kind of discouraged by that because I was hoping, yeah, like you guys, I want to make the fast path be the callback full and just say, okay, hey, we're just going to call you on the same stack, like especially for fused adapters. Hey, async lifted export connected to an async lowered import. I'm going to fuse those, and I'm not going to have to insert a new fiber in there. I just want to make it a direct call. But if we're being super conservative and we, there's dimensions in the design space, I guess. So,
The other possible wrench in the works is with Wasmtime, with epochs and fuel, we unconditionally need a fiber no matter what because
uh,
you're in the middle of execution. We're like, nope, we want to go run something else
right.
on the host. So I also agree that there's probably going to be an unconditional fiber no matter what. It's more of just kind of how exactly that's managed and the cost that it imposes and things like that.
Yeah.
But yeah, we can move on. I think it's okay.
Yeah. And it's also not about whether we have a fiber, but whether we need to switch fibers every time we go from component to component, which would be in the conservative case, what you need to do. But yeah, I would like to see us optimize that and not have to do that. So, any other questions, comments before we move on? Okay. Okay, into WASM time. This is where things get interesting. Um, okay, so the RFC goes into a lot of detail about kind of what I'm proposing, but here's kind of a summary. The first thing I want to mention is this promise struct that I introduced, and the problem that this is designed to solve. And I will not claim to have exhausted the solution space here, but this is what I came up with, is that the current way async works in WASM time is such that a host function that is kind of created using this func wrap async call basically returns a future that has that closes over, so to speak, the store context moot, which basically means we're monopolizing the store as long as that future is alive, and that turns out to be a problem here because it gives you concurrency, just fine concurrency on the host level. I mean, you could go off and call functions in other instances with other stores, or you could do stuff that's unrelated to WASM time, whatever you want, but it's not concurrent with respect to the guest with respect to that instance. And so we have this problem of like how ideally the ideal solution is somehow we be able to say, I want to create a future and I want to give it access to the store context moot, but I only want it to have access to that store context moot between awaits, basically when I'm actually pulling it and not otherwise. But there's no way to express that right now, and you'd have to kind of redesign future to make that work. So I tried to do the best thing I could, which is I've got this promise thing, which basically wraps a future, but it exposes an API that basically says, if you want this promise to make progress, you need to give me a store context moot. And there's also a promises unordered, which is inspired by the futures create futures unordered, which basically lets you say, I've got a whole bag of these promises. Let me know when any of them make progress, and here's the store context moot that you need to kind of pump the host event loop. Um, I don't know if that quite made sense to folks, but it's fundamentally trying to solve this problem of multiplexing access to the store in a way that's concurrent both with respect to the host and with respect to the instance that we're running. Nick.
Um, I foresee maintenance burden here,
Mm,
where all of the combinators and helpers and stuff
mm,
that exists for the futures ecosystem, like we're going to have to make a crappy reimplementation of. Um, so I don't know what the best solution is here, but like one thing that potentially pops to mind
Mhm.
is still having a promise type or something like that, but maybe not like a trait.
Mhm.
And then implementing future for like the tuple of a store context mute and
Mhm.
the the promise.
Mhm.
So that you can basically like bundle them up and then await on them, but then like
Mhm.
unbundle them immediately. I don't
Right.
know how well that would work in practice,
Yeah,
but
yeah.
first thing that pops into my head.
Definitely, yeah. Good, interesting insight. Yeah, I'll have to think about that. For what it's worth, I've been able to do a lot of with just a single combinator, which is to say this promise is unordered. I've been able to do a lot of stuff like a very non-trivial WASI HTTP thing where I had trailers and co body content and requests and going in all directions, and I was able to kind of manage all that. So even without the full library of combinators, in fact, with just a single combinator, I was able to do a lot of non-trivial stuff. Um, so, but yeah, I am definitely, to be clear, super open to other ways to approach it or things we can build on top of it or whatever. No. Cool. So yeah, there's promise, and then the remaining new public APIs use this promise thing, like func wrap concurrent and func new concurrent. They there's it's basically the static and dynamic variations. They both return promises, and so that means you can call func. Oh, let's see. Well, and then I'm sorry. No, sorry. Not scratch that. It's call concurrent that actually returns a promise, and then some other stuff, some functions for reading and writing streams and futures that return promises. The func wrap concurrent is actually for the opposite, where we actually are providing a host function. And I guess since it's the next bullet item, I'll just talk about that. So func wrap concurrent and func new concurrent are distinct from the existing func wrap async and func new async ones in that they can execute concurrently with respect to both guest and host. And so in that case, we have, let me peek over here at the RFC to kind of show you what this looks like. I'm not, this is another thing I'm not super happy with, and so I could use some feedback on. Uh, make that bigger, jump down to this. Um, yeah, so so this is the signature for front rack concurrent. This might not be perfectly accurate. It might be a little out of date, but it's pretty ugly, right? And the reason for it is basically what I came up with here is I wanted to return a future that didn't monopolize the store. So what it does is it actually returns well, this function takes a function that returns a future which has access to the store initially. Wait, no, sorry. Wait, let me walk that back a little bit. It takes a function which receives the store as a parameter, returns a future which does not close over the store because it's declared static, and we communicate that to the to the compiler by saying, "Hey, this return future is static, so it can't possibly close over this ampersand moot." Uh, and then that future itself returns a function which gets one last access to which again receives the store access to the store as a parameter, and so it gets basically you get access to the store before you await and after you await, but not while you await. That's what this is trying to express. And that's the way I kind of handled so this is separate from the promise thing. The promise thing is more comes into play when you're actually calling from the host to the guest. This is where we're calling from the guest to the host. So that's what I came up with was basically you can get stuff, you can grab whatever you need out of that store, or probably more likely the data attached to that store. Uh, then you can return the future that does the wait as much awaiting as you want to, and then that thing returns a function. Questions, comments about that? It's kind of mind bending. And there's an example here that kind of shows how this works with WASI-HTTP and trailers and whatnot. And basically, we're getting access to the store, we're getting access to the trailers, but this is trailers is a future. And so it's pretty ugly, but yeah, we return a future that then we can await on the trailers. And then it turns out in this case, we didn't need to do anything with the store before we returned the value. So we just ignore the store that it gave us. And then we actually return the trailers, the concrete trailers that we actually got, if any. And that's also our opportunity to kind of throw an error or return an error if something went wrong.
And so if I understand correctly, you get access to the store at the start,
Mhm.
and you get access to the store at the end, but
Mhm.
there's no way, like while you're awaiting, if you
Yeah.
need to access the store again, you can't do it.
Right. And so that means you have to, up front, you need to get anything out of the store and possibly that could be that thing that you got out of it could be an arc of a mutex of something that you can then use in the future. Uh, so you would have to design your data, kind of the data that the store is wrapping in such a way that, if you do need access to something that was in the store, that you can kind of share access with the store. Now, the alternative, I mean, the brute force alternative here would be just to say, hey, we're using arc of mutex of store everywhere, in Wasmtime. And then, sky's the limit, right? You can pass that sucker all around. But I don't think we want to do that, right? That imposes unreasonable overhead over a lot of existing use cases, and so on. Alex.
To make sure I understand, if you scroll a little back up to the
Uh,
signature, this is effectively func wrap async, except that the final value is itself a closure as opposed to the final value being the final value.
and the crucial thing being here, this static, basically saying, hey, we promise that the future we're returning is static. And that basically says, well, then you can't possibly close over this store that I gave you, right? So yeah, but otherwise you're right.
So one idea I just had, which I forget if we already talked about this a long time ago, or if it didn't or did not pan out, but the n parameter here could perhaps be a trait based on the return value of the feature.
Uh-huh, sure.
So like instead of being fn once, it would
Sure,
basically
sure.
be thing, and
Mhm,
then we could somehow make thing work by default for like strings and integers and various primitive types.
mhm.
So by default, you wouldn't have to do anything, and by default,
Yeah,
we'd say just forward it directly, just don't even put it in the
yeah, yeah.
store.
Mhm,
But then you could opt in on a one-off basis of like,
mhm,
oh well, my resource needs to go into a table, so yes, I want the store, I want to go do the thing.
mhm.
I don't know if that would actually clean up a whole lot here, but
Yeah.
that's one possibility.
That's helpful. The good news I'll mention here is that like I implemented basically the draft of WASI HTTP 0.3. There were only two functions that were actually async in that whole interface. And so those were the only ones that had the big ugly signature and the big ugly body, I mean, somewhat big ugly body. Everything else was like it was just synchronous and I just used func wrap, without any sort of async or anything. So the degree to which this uglifies the code in practice is not maybe as bad as you would think. So
That's a good point.
cool. Any other comments there? Questions? Okay. I mean, these are the most difficult parts here, and we'll revisit some of it. It actually gets worse in terms of wrestling with static and and lifetimes and whatnot, but we'll get into that in a moment. But as far as exposing the ugliness, the stuff we'll get to the ugliness that's internal to the implementation. I'm kind of focusing on the ugliness external, that users will be exposed to at the moment. So yeah, anyway, func wrap concurrent is for host imports. Call concurrent is for guest exports when you're calling them. Um, Pretty straightforward. In both, in the case of call concurrent, this returns the promise thing we mentioned, and then you can basically do futures in order. You can call concurrent, 17 times, and so you'll have 17 outstanding export calls, which in various stages of progress, and then you can do a promises unordered. And I do have some examples actually in my PR now, end-to-end tests that use WASI HTTP in a pretty realistic way that uses that and juggles a bunch of stream reads, stream writes, future reads, future writes, call concurrents, doing all this stuff at once. Um, so there's that. And then the new public APIs for Stream Reader and Stream Writer kind of correspond with what we saw on the guest side with wit-bindgen. Then those return when you call write on a Stream Writer, you get back a promise that you can then multiplex with any other promises you have around, and likewise for future writer and reader and so on. So see the PRs and or the RFC for details there. Um, New options, just two new options for the host binding generator. Concurrent imports basically says for any of the async uh, the async bindings we're generating for imports, use func concurrent instead of func async, which means you have to kind of structure the types differently than if you were using func async. And likewise, concurrent exports for any things that you want to call concurrently, you'll use call concurrent instead of call async. And part of what I'm proposing in the RFC is I actually want to deprecate func async altogether, because in this new world, even if you're expecting to load guest code that doesn't use any of this new async API stuff, um, we need to start to conservatively expect that sooner or later we're going to load such a thing. And func async is very dangerous in that respect because it gives you sort of a false sense of security. It's only async with respect to the host, not with respect to the guest. And we want to be a good citizen and convert all those to func concurrent so that it's async with respect to both. Because otherwise, you're basically blocking the whole instance at that point. And if you still might want to use func without the async or the concurrent. That we won't deprecate because that's the case where, hey, I've got nothing to block on. I'm going to return a value and that's it. So func is fine, and func concurrent is fine. It's func async that just basically has no use anymore, is what I'm proposing.
The one use case that I can think of is that you don't want to create that tick static feature. You do want to actually close over the state because for some reason arc or mutex or whatever is a little too expensive.
Okay.
But I agree with the thrust of like we shouldn't have the words concurrent and async both stable and both like
Uh-huh.
accessible. So I agree with you. Some things gotta go, but I would want to leave the door open and maybe we should just rename async to something else, which is the same capabilities, but renamed to clearly indicate it's actually blocking from the guest's point of view.
Okay.
But I also think that's also debatable as to whether we want to. But that's the one piece which concurrent doesn't give you effectively.
Yeah, well, I think I might want to debate you a little bit more on that, but I don't think we'll do that right now since we don't have a lot of time. But I actually feel pretty strongly that we should just get rid of this completely. And to be clear, I don't think necessarily we should get rid of call async. Call async doesn't really have any of the drawbacks that func async has. Basically, call async is just saying I, as the host, want to call this export, and I don't have anything else to do besides wait for that to be done. And so call async is perfectly valid. I think we leave that around. Call concurrent is the more advanced case where actually I do have other things I want to do with this instance while this call is in progress. So I would say definitely don't deprecate this, and I'm going to campaign pretty strongly that we get rid of this. So, but we can revisit. Um, Okay, so and then just rounding out the stuff that we're doing for Wasmtime, built-in implementations for task return, task wait, stream new, and so on. I mean, there's a lot of details, task back pressure. There's a bunch of new intrinsics. Some of them are pretty trivial to implement. Some of them have pretty deep fingers into the rest of the implementation. All the details are in the code. Won't spend a lot of time on that, except that they are there, and we had to plumb them through from WASM parser all the way through the tortuous path, through Wasmtime environment and so on, and fused adapters and all that. So all that works, and then we've got fused adapter support for all the combinations. So we can compose async with async imports with async exports, async imports with synchronous exports, async. Wait, oh, okay, I mistyped that. That was just supposed to be sync to async. And then also we have the dimension of stackful versus stackless. So there's even more combinations here than meets the eye. All those work with fused adapters, as far as I've tested them. Okay, so now these are into this is the last slide, so to speak. Implementation headaches with Wasmtime. These are things that are ugliness that won't aren't exposed in the public API that I'm proposing. They're just details that we as Wasmtime developers will need to wrestle with and possibly, room for improvement. So the first thing that was most troublesome and complicated a lot of the implementation is that the T in store of T might not be static, and that's very much by design. It's a feature we like, so it can have a lifetime associated with it. This could be a stack allocated thing of some kind. Um, but the trick is now we have to defer lowering parameters and lifting results indefinitely because there might be back pressure, explicit or implicit back pressure. So when we do this, we start a call, we might need to return from, call concurrent without actually lowering those parameters. So not only do the parameters themselves, so clearly the parameters need to be synchronous. And although the host binding generator allows you to kind of specify asynchronous or borrowed parameters, you can't use that mode here. That's fine. It doesn't affect existing code. But uh, but also we run into this issue, and this is something that Alex and I took a look at. I'm calling all Rust experts. Maybe you can help me with this. I've got a link to a Rust playground that sort of distills down the issue here, but it has to do with the Rust compiler in sufficiently not even that complicated cases starts to get confused about variants. And so basically, if you have a type that involves a closure, an FN once, for example, that takes a parameter that has a lifetime, it can get confused about whether the closure itself inherits that lifetime, and it shouldn't. Like if Alex and I if we think we're understand this correctly, we think it's just a limitation in the type solver in Rust C. But basically, we end up the static bound becomes more viral than it should, and as a result, punchline of all that is that I have to convert to a raw pointer in places I really would rather not, and then cast back to this thing, which is horribly unsafe. We're cast into this thing that could have a limited lifetime and whatnot uh, in way too many places. And I would love someone to save me from this awful situation. And I'd be happy to do like a one-on-one follow-up call or whatever to kind of go into the details of what we ran into there. Questions or comments about that? I know it's kind of vague. You can click on the link to see some details, but let's see, how much time do we have here? Yeah, we've got about 12 minutes left. We can come back to it if people want to talk about it more if we have time, but that's a thing. The other thing, and we kind of went into this. Oh no, actually, this is sort of related to the problem we were talking about earlier with promises and funk wrap concurrent and whatnot. But it's a little more. It's more. There's more to it than that. In that, in general, safely multiplexing access to the store is tricky, but especially when it interacts with this, the fact that we're converting from ampersand moot to star moot, basically from references to basically, which are, of course, non-aliasable, to mute pointers, which are aliasable, and then switch back to ampersand moot, we have to be really careful about that. And I've tried to be careful about that, but I'm sure there's holes in it, and I'm not even sure. I might be being paranoid about it in some places where I shouldn't. But sort of the bottom line is that we have a lot of functions which we call them and we pass a store context moot to them, which is basically just a new type wrapper around an ampersand moot, essentially. And they may have to, in the course of their business, call into WebAssembly code, which means turning it into a star moot, which then becomes aliasable and whatnot. And if I'm understanding correctly, the rules, which are still emerging in Rust for this kind of thing, and Miri might hold us accountable here. I haven't gone down that road yet. That once you kind of convert from an ampersand moot to a star moot, you can't use that ampersand moot anymore. It becomes invalidated. And the caller and the way I've sort of reflected that in the type signatures for a lot of these functions is that any function that might transitively convert to a star moot also needs to return the store context moot that the caller should use going forward because the one they passed in is no longer valid. And basically, I'm concerned that like we'd have some sort of aliasing violation. The LLVM would take advantage, in its zeal to optimize things, of that if we didn't return that move and require that the caller kind of use that in preference to the one that it passed in, that things would break in subtle ways. Any comments about that from the Rust experts or thoughts or anything? I do wonder if this already is potentially an issue. Basically, anytime you take a store context moot and then call into guest code, we're already doing that today, I feel like. And I don't know if I didn't see anything that was kind of like being trying to address that. And I know we're using Miri in our testing, so maybe this is just a phantom issue that I'm kind of blowing out of proportion. I don't know.
The T one, I not so much, but the N mute one, you're right of we most likely messed this up today. We most likely are going against we are most likely in an unsafe situation we don't actually are aware of. Miri, unfortunately, isn't able to turn any of this up because that requires actually executing compiled code. So
Uh,
we are very close to possibly being able to use this with pulley, which has its
okay.
own suite of issues and its own suite of like prominence and mute stuff. So
Mhm.
I, if I were you, I would generally not worry a whole lot about this, especially if you're already going the route of like taking and mute and returning and mute. I guess is that's probably 99% of it. And really all we can do here is basically run Mary and just see if it
Yeah.
complains. And
Well, okay, that's helpful. I guess my other question then is, am I being too paranoid? Should I, because part of what makes the code in concurrent.rs right now so freaking ugly is because I'm both in so many, it's been kind of viral. In so many functions, I have to both pass in and pass back. And not only that, like when I'm resuming fibers and whatnot, like I have to basically, the fiber can basically sometimes return back a store context moot. This is how it communicates whether like the fiber, depending on what like the host functions it called, it might end up have monopolizing the store context moot. So when that fiber suspends, I have to make that explicit that, oh, now whoever resumed that fiber now no longer has the access to the store context moot they passed in because now it's being monopolized by some future somewhere in that other fiber. Anyway, it gets really complicated, but I guess what I'm saying is a lot of the ugliness in that code, not all of it to be sure, but a lot of it comes down to my bending over backwards to deal with this. And one possible outcome is Mary says, "Ah, it's fine, it's okay," or some language lawyer tells us, "Oh, actually, we can get there for some certain reason. It's okay." Then I could pull out a lot of that. So maybe what I'm looking for is direction. Like, do we stay paranoid here, and wait until we have a good reason not to, or to be paranoid? I don't know.
do you feel confident enough to be able to sort of reduce all of this to like remove all of Wasmtime, just like
Mm,
kind of like the Rusty issue, run that through Miri
yeah,
and
yeah,
see like,
it's a
because,
good idea.
okay, so I
Mhm,
would do that. I would run
mm,
that through Miri. So
mhm.
your current pattern, make sure it passes Miri, and then also the pattern you want to do, which is not returning it,
Yeah,
see if
yeah,
that passes Miri.
sure.
My guess is I don't think the trade-off is worth it if it's
Mm,
severely complicating the code internally. I think that's probably a too much of a price to pay.
yeah.
I suspect the fallback we can do is that the sort of source of truth is a star mute, and we
Mm,
predominantly have a star mute all over the place, and then
mm,
we temporarily promote that to an ampersand mute. I don't think we'll
yeah.
have any issues with Miri whatsoever. We might need to just refactor to do that instead of predominantly having an ampersand mute.
That's where my mind was going to. Yeah. So I think that could be at least our last resort, if nothing else. Yeah. Okay. I mean, the general pattern here, though, for looking at both of these issues, is there's a lot more unsafe code than I would like. And Alex and I were talking the other day. He pointed out a way that I can kind of at least package that into a macro, that a safe to use macro that uses unsafe behind the scenes for some of these intrinsics. It turns out the way I had implemented intrinsics, I was following the wrong pattern for that, and we can reduce the unsafe code there. But for anybody who's reviewing this code, I am very eager to for suggestions on reducing the amount of unsafe beyond what Alex and I have already talked about. Cool. Uh, just got about 4 or 5 minutes left. Any general questions, comments, concerns? Right.
I can definitely say thank you so much for preparing this whole overview and getting us all together. And also, you've done clearly a massive amount of work so far. Very much thank you for doing all that. And I will, just on my part, I will try to get to the wasm-tools PR either this week or, well, yeah, tomorrow, today or tomorrow. I'll try and get to the wasm-tools just because I suspect that'll be really easy.
All right, I appreciate it. There's a lot of code there. Most of it's test stuff and like blessed, golden images and stuff like that. But yeah, happy to do that synchronously or like if I any questions or anything like that. Cool.
Thanks a lot.
Yeah, thank you everyone, and enjoy the rest of your day. See you around.